Hello. So in this video I'd like to compare the performance of a Luger, in this case a shooter DWM Luger, with two different striker spring length. This is the original in very good condition, 50 millimeters long, and this is original but cut by 20%, so this is 40 millimeters long. The striker in this case is been the protrusion has been decreased to about 0.45 millimeters. So in all experiments, this is the protrusion that we have. Trying to focus this thing, which is quite small. Now I have shot the Luger with the standard spring with a firing pin protrusion of 0.45 millimeters, and it works fine. It kind of pops the primers, okay, and there's no issue. I tried it in different guns, different modern primers, and all worked very well. So we know that the striker, the protrusion, the firing pin protrusion is a bit, the standard protrusion between roughly 1.1 and 1.35 millimeters. That's quite, long for modern primers, and the firing pins don't need to be that long. All right, so what effect does a cut striker spring have on the performance of the Luger? Okay, so I'm gonna basically show two experiments, one with the cut spring and one with the original uncut spring. By the way, in both cases with the short firing pin protrusion, both work the Luger fine. The Luger shoots cycles fine, so there is no issue there. All right, so I'm going to take the longer spring. Here's the firing pin. Again, this is aftermarket. I'm pressing here. Okay, and with a screwdriver, okay, put this in and see the protrusion over there. Okay, and this is fairly stiff. It takes some really effort to push this striker retainer, firing pin spring retainer in. Okay. So now we're gonna put this in the upper. Oh, these are remnants from an experiment I did, so I'm gonna remove those sticky tapes here. Sorry about that. Okay, there we go. So this is clean. Let me wipe it. Okay, so slide in the toggle in. Now this is a 1937 Krieghoff. Actually, this is a fantasy. It's based on a DWM gun. This is one of my shooters. Firing pin in. The main toggle axle in. All right. I need to put this in. Take down lever. side plate, very good. Okay, the gun is, you know, no mag, no live ammo, so that's being checked. We're good there. Now, the first thing one observes is that with the stiffer, longer striker spring, okay, now if I move the toggle slightly, you know, pull it up and let go, you know, it goes down. Now remember, this is basically the striker has been set. It's ready, you know, to if I press the trigger, it'll, you know, you can hear it, it'll fall. So here again, the striker is set, and if I move this slightly up, it'll basically come back down. But then if I make the angle bigger, then it stays open. Now the reason for this is that, first of all, is that the striker spring is acting against the main spring, and in this case it's a original stiff, you know, new spring. So what the main spring is doing is basically pushing on the coupling link on this, the back toggle, and it's trying to push it down. Now some of that force, so that transfers here, and the force has two components, one vertical and one horizontal. The horizontal is weak, and that's the one that's gonna push the breech block in. Okay, so some of that force from the main spring is being lost by pushing down, which is not useful work on the breech block. Okay, so that's basically the reason that you know, some of the Lugers with a stiff, essentially a striker spring, that's what's causing this to stop like that. However, if you chamber around, you see the main spring is basically canceling the effect of the striker spring, and there's still some force to keep this down, to keep the bullet, the round chambered basically. Okay, all right. Now we're gonna see with the shorter spring that you know, you're gonna see some major changes when we do that with the shorter striker spring. Okay, so the other thing here is that with the stiffer, I shouldn't say stiffer, with the standard length spring, when the gun recoils, okay, this goes back like this, there's some significant amount of energy that gets absorbed by setting, by kind of compressing the striker spring, okay, and that essentially is going to you know, reduce the amount of you know, the collision of the tail of the back toggle with the back of the frame. And I'll also have an experiment to show you what happens with the different striker springs. Okay, now let's now switch to the shorter striker spring. Okay. Now before I do that, I should also say that the longer spring, when this goes back, you know, up on the back, the recoil, okay, you see that this striker spring guide hits here, the coupling link over here, okay, and you see it. So the stronger the spring is, the more cushioning effect will have, and kind of also help reduce the collision of this part of the toggle back, the tail of the toggle with the back frame. Okay. So let's go to the shorter spring. There we go. Okay, so again, I can feel this is much looser, maybe at least like 50% or so than with the other spring. You can actually feel that. The protrusion is the same because it's the same striker essentially, and you can feel it like trying to move, in resetting, compressing the striker spring. This requires less effort relative to when we had the full length striker spring. And when it comes to the collision I mentioned earlier, this is not going to be as cushioning as the shorter striker spring as in the case of the standard length spring. So let's put this in. Okay, there we go. And okay, and the first thing we notice with the shorter striker spring is that, you see, no matter how the angle of this toggle is, it'll always go down. It'll always go down. That's because the mainspring is not facing, it's facing reduced resistance from the striker spring. So that's nice. That's nice to have like that. Maybe that's a advantage of a shorter spring. Now the question is, would the shorter spring with a firing pin that's only has a protrusion of 0.45 millimeter, is it going to pop the primer? And the answer is yes, which is kind of surprising. Even with a 20% shorter striker spring and a firing pin protrusion of 0.45 millimeter, the impact is significant to shoot the rounds, and there's no issue there. So should we just, and the modern primers are softer, so maybe than the original primers on the 9mm from the period 9mm rounds. So why don't we just then reduce by 20% the length of the striker spring and shave down the protrusion to maybe not necessarily 0.45, this is kind of an extreme now, but maybe 0.6, 0.55, 0.6 millimeter, 0.65 millimeters. Okay. Well, the gun will work fine, and they'll have this nice way of the toggle to go down even when the striker is set. See? Okay. But there's no free lunch. Something is going to have to give, and this is essentially explains what's going on in here. Is this picture? So I basically tried, this is the image of the standard length striker spring, 50 millimeter, and you see we put this is from a Target, this stick that you put in, and this, if you scratch it, it'll turn greenish, yellowish. Okay, so this is after shooting one round with the original 50 millimeter spring uncut. So you see that spring is helping absorb some of the recoil energy, enough that the tail, bottom tail of the rear toggle is barely hitting the frame. And in comparison, this is striking here, the shortened striker, the 40 millimeter ones, you see how much the that it is really, because it's a weaker spring, some of the recoil energy is absorbed really by the rear frame. So that's not something good. That's a negative basically for shortening the striker spring one should be aware of. Okay. All right, so I'll stop it here. Hopefully you see some useful results from this video. Hope you enjoyed it, and thank you for watching.